Okay, here we go. Quick video about reflections. You don't have this page in your notes, but I just wanted to use it to point out that when we talk about reflections in coordinate geometry, we're talking about the same thing as reflections in the world around us. This long pool here is actually called the reflecting pool, and it sits in between the Lincoln Memorial that you see here, and this is what's at the other end, the Washington Monument, and you can actually see a very nice reflection of the Washington Monument here in the reflecting pool. So there's that. All right, when we look at reflections, we're looking for a mirror image, and we're looking for a line of symmetry. So in this case, the line of symmetry happens to be this y-axis. Okay, so the y-axis is the line of symmetry. So if I could fold my computer screen in half along the y-axis, then this triangle would match up with that triangle, and we would have two congruent triangles. They've been reflected. We can go either way, since we've been going left to right. That sort of seems logical. If we make this triangle, we'll just label the points. Maybe we'll call this triangle CAT, C-A-T. So then you have to think carefully. The reflected image, obviously this is A prime. C is going to be this one out here. This is C prime, and this is T. Okay, so it's important that the points match up carefully, that if I did fold this in half, that C and C prime would match up, okay? If you look carefully again, we're reflecting over the y-axis. The y value for A is still 1, 2, 3, 4. So A and A prime are still at 4 for the y value, okay? So if we do point A, it's at negative 1, 2, 3, 4, 5, negative 5 for x, and 4 for y, and A prime is now at 1, 2, 3, 4, positive 5, 1, 2, 4. So 5, 4. So what happens is if we start to write a generic rule, x, y, okay, looks like the y stays the same, and the x went from being negative to being positive. So what we say is that we're going to take the opposite of whatever x is, and by using the negative sign, that takes the opposite of it. If it was negative to begin with, the negative of a negative makes it positive. If it was positive to begin with, obviously it becomes negative. Let's just check that quickly. We'll use point T. Point T is negative 2, 1. T prime is positive 2, 1. So again, the x value changed, the y stayed the same. That's if it's over the y-axis. So the y-axis, the y stays the same. Let's see what happens when we reflect it over. Here it is, the x-axis. So the x-axis, in this case, is our line of symmetry. And I think we'll do the same thing. This was C, A, T, and so this is C, this is T, sorry, C prime, T prime, A prime, okay? If we look at point C, which is 1, 2, 3, 4, negative 4, positive 1, C prime is negative 4, negative 1. So it appears as if the xy, okay, the x's stayed the same, the y switched from being positive to being negative. So it's going to be the negative of whatever y is, or the opposite of whatever y is. If y is negative, it becomes, excuse me, if y was positive here, it becomes negative here. Let's just check that. Let's see, A is not quite on a point, so let's do T. We'll do T is negative 2, positive 1, So t prime becomes negative 2, negative 1. X-axis. So on the x-axis, the x stays the same, the y flips. Here's where we have a line of symmetry that's not the x or the y-axis. This line of symmetry is when x is equal to 2 is our line of symmetry. And so we have to be very careful. This is 1, 2, 3 away, if this is point T. So we need to go from the line of symmetry, 1, 2, 3 away is point T prime. And then 1, 2 and a little bit, 1, 2, and here's going to be C prime. And this is 1, 2, 3, 4, 5, 6. This is A, this was C. So 1, 2, 3, 4, 5, 6. A is going to be A prime is going to be way over here. So if I carefully draw this in, sort of carefully draw it in. Okay, we've reflected over the line of symmetry of x equals 2. Well, this is sort of like a translation and a reflection. So we're going to have to add something on to take into account this x equals 2 part. If we look at point A started at 1, 2, 3, negative 4, 1, 2, 3, positive 4. And it became A prime at 1, 2, 3, 4, 5, 6, 7, 8, and 4. So it looks like the y stayed the same. So if we're going to do a generic rule, x, y stayed the same, but we added and we reflected. So if we had just reflected over the y-axis, excuse me, A, which was 4 away here, would have just been 4 away here. This might have been A prime, but it's now 1, 2, 3, also 4 more. So it's going to become the negative of x, the opposite of what x is, plus 4. Let's just double check that with t. T is at negative 1, 1. If we follow the rule, the y stays the same, 1. The negative 1 is going to become positive 1, right? Negative of negative 1, which our x was, plus 4, becomes positive 1, plus 4 is 5. And here it is, 1, 2, 3, 4, 5, plus 1. So that works. Awesome. This special kind of rule, where you have to add something onto the x, is sort of a combination of a translation and a reflection. Let's look at a reflection over the line y equals x. So here's our line of symmetry. Okay, this, in case you get confused, is the same thing as, right, in slope-intercept form, 1x plus 0 would be this line. We start at 0 and we're going up 1 and over 1 each time. But we don't have to write the 0, and we don't have to write the 1, which is why it's just y equals x. Well, let's do the points. We'll just do A, B, C. I'm not feeling very creative at the moment. Okay, if I reflect this over, if I fold my computer in half here along this diagonal line, then this becomes C prime, this becomes B prime, and A prime is down here. So now I can check a point. Maybe I want to check point A. Well, right now A is negative 3, positive 2. And A prime is 2, negative 3. So it looks like the y became the x, and the x became the y. And that is our rule in this case. We're just going to switch the positions of x and y. So let's check that for B. Point B is negative 2, 1, 2, 3, 4. Negative 2, 4. This becomes, if we're just following the rule, then I would switch it so the 4 becomes my x and the negative 2 becomes my y. And let's just check that. Is it 1, 2, 3, 4, 1, 2? Yeah, That works out nicely. So this rule is just switch the x and the y when it's the line y equals x. One more reflection here. This is like the line, whoops, y equals negative 1x plus 0. Okay? So again, if we have a, b, c, this is the negative diagonal. So we're reflecting, so this is c prime, this is b prime, and this is a prime. Okay, let's see what happens here if we do a is 0, 1, 2, 3, 4, 5, and a prime is 1, 2, 3, 4, negative 5, 0. So it's hard to tell with the 0, so let's do another point. Let's do b. b is 1, 3. b prime is negative 3, negative 1. So not only does it look like the x and y are switching places, but it looks like they become negative as well. So the y is going to go first, this 3, and it's going to be negative. The x is going to go second, and it's going to be negative. If it was already negative, you would make it positive. So if we just check that with point C is negative 1, positive 3. If we follow the rule, C prime should become, the y is going to go first and become negative 3. The x goes second, becomes the negative of negative 1, should be positive 1. And there it is, negative 3, positive 1. Cool. So let's just reiterate all the different rules, because we have 4 different rules here. If we're just crossing the x-axis, then the x is going to stay the same, and the y is going to become negative. If we're just crossing the y-axis, then the y stays the same, and the x becomes negative. Across the line y equals x, we're just going to switch the positions of x and y. And if it's y equals negative x, we're going to switch the positions negative y and negative x. Make sure you write those down. Last part, not very different from before, but we just want to see what changes and what stays the same. Okay? The changes, obviously, are the position for the coordinates. What stays the other thing that changes, if you go back and look, one more, this slope here was positive from C to A, but it was positive up 2 over 1. Here, the slope is positive, but it's up 1 over 2. So the slopes also change. The slopes change. What stays the same are the lengths and the angles. So essentially the shape. The shape stays the same, but the directions of the slopes changes. All right, we're going to practice this in class. See you then.